We can close the fuel cycle, meaning that after the spent fuel has been cool for a while, it is sent to a reprocessing facility. There, the fuel is dissolved, usually in nitric acid, and the plutonium and uranium are chemically separated from the fission products. Once this is done, further separations can be done, and the reprocessed uranium, plutonium, minor actinides, fission products, activation products, and the cladding can be separated into individual streams coming from the reprocessing plant. Reprocessing has certainly evolved over the last 50 years, with relative importance changing with time. At first, reprocessing was strictly done to produce plutonium for nuclear weapons. The Cold War ended and the emphasis shifted to recycling plutonium, uranium, and some actinides as fuel for breeder reactors, thereby increasing the amount of energy that could be extracted per unit uranium by a factor of 60 or more. After the U.S. postponed development of breeder reactors, reprocessing was studied as a way to make MOX, or mixed oxide fuel, for use in power reactors, increasing the energy return by 12%. As the repository neared acceptance of spent fuel, studies were conducted to see if minor actinides could be extracted from the fuel and destroyed by nuclear fission, either in a power plant or in a special reactor built to do this. Also, troublesome long-lived nuclides such as technetium-99 and iodine-129 could be extracted and transmuted to something with a shorter half-life by neutron capture. Reprocessing can also separate low-level from high-level waste so that the repository can be more compact. Finally, there are nuclides in the spent fuel that have value in industrial applications. All this sounds appealing, but has it been done? Yep. Commercial fuel has been reprocessed for years in Europe, Japan, India, and Russia. Reprocessing does wonderful things to the disposal of nuclear waste. By removing the minor actinides, uranium and plutonium from the waste, the reactivity of the remaining activation products and fission products drops below the reactivity of the original uranium ore body in 300 years. By 600 years, the toxicity is such that you could literally eat large amounts of the waste without harm. I doubt if it would taste very good, though. Here's a graph that shows the radiotoxicity of the waste as a ratio of the toxicity of the original ore body as a function of reprocessing options. If we build breeder reactors, we can greatly extend the amount of energy we can extract from uranium. Reprocessing is integral to breeders and closing the cycle. Should we reprocess? Probably. Maybe to solve once and for all any questions about disposal of nuclear waste, or maybe to extract all the energy that we can from our uranium resources. I'm not smart enough to look that far into the future. Right now, several studies suggest that there is no economic reason to reprocess.